All right, we start looking at some of the problems from the previous solving log equations worksheet, okay? Where what we have is log equations which are going to be solved with exponential forms rather than exponential equations which are going to be solved with log forms, okay? So with this guy, you notice that they all have 3 in common, so we're going to divide everybody by 3 and we'll clean that up a little bit, okay? Giving us this. When we have log A minus log B, we should remember that's log A over B, okay? It does throw up a red flag telling us that we need to be cautious about our answers, okay? We'll take this out of the log form into the exponent form because this is log base 10. That means 10 cubed, okay, which is 1,000, okay, is going to give us that, and then we're going to just solve that for x from there, okay? So that's just going to be cross multiplying and solving for x, okay? Which is, let's see, cross multiply, solve for x, and there you have distributing, and so we should be able to easily solve that for x, okay? Yeah, okay. All right, let's take a look at this problem, which is number 11 from your worksheet. Again, the first order of business is to condense these, okay? Again, a red flag is thrown up every time. And then just get it out of the log form. So this is 2 squared equals that product of x plus 1, x plus 4, okay? And of course, then that's simply 4. And we're going to expand this, okay? So we're going to expand that expression out. And then, yeah, it looks like we lose 4 off of both sides. That's good, okay? And then that's easily factorable, giving 0 and -5. Note the -5 is not considered, okay? The 0 is fine because when we put 0 back in, we're still taking the log of 1, okay? So it didn't even consider the -5, although it wouldn't be thrown out because it's negative. It would be thrown out because when inserted back up in here, it produces a negative argument, okay? You know, ordinarily, the log of 0 is undefined, but when 0 is replaced back in here, we're still taking the log of 1. And of course, the log of 1 is 0, and the log base 2 of 4 is going to be 2, so that balances both sides. Now this is a good one because this one is a little deceptive. This is number 13, okay? I would just, first off, I would use my power rule over here, okay, and bring that down. And now I do a substitution because I'm going to, this is log x, okay, which means that this is u cubed equaling 2u, okay? So at that point, you should be able to resolve it, okay? So we'll just bring everything over to one side, pull out the common factor of u, okay? And then from which we will get u equals 0 and u equaling the square root of 2, okay? But then again, we have to remember what is u. U is log of x. Log of x can never equal 0, if you recall the graph. The log of x can never equal 0. And the log of x is never going to, it could equal, the log of x could equal a negative root 2. So we're going to have log of x equals root 2 and log of x equals negative root 2, okay? Okay, I seem to have let that problem go a little too quickly. I'm going to just auto-finish that and show you that we come back and we see that the log of x equals root 2 and the log of x equals negative root 2, which is implying x equals 10 to the root 2 and x equals 10 to the negative root 2 as our possible answers, okay? Oh, and pardon me, the log of x equaling 0 is at x equals 1. Okay, there is a solution to that. I had misinterpreted that. So okay, let's do another problem here. Okay, here I'm going to see. I see 1, 2, 3 log terms. So basically, I'm going to shift everything to one side. Okay, and then I can get this, and then I'll send that 2 over there. Okay, so I'll add 2 to both sides. Okay, just to notice that these 3 log terms can come together. That's log A plus log B plus log C. So that's just the product of those 3 expressions. Okay, and so and again, a red flag comes up cautioning us. And then from here, this, we're going to take it out of the log form and say 10 squared is 100. So I'm going to take it out of the log form right there. This looks a little awkward, okay, but we have to work it out. We'll see how it works out, okay. 10 squared, of course, is 100. This product of binomials, let's see what that gives us, is 6x cubed minus 7x squared plus 1. Okay, at that point, I guess I'm going to pull everything over to one side. Yeah, I'm thinking this is, it's awkward. We have to look at seeing if we can find factors of that, factors that work within there. That's going to be a little awkward, okay? But you know, that's where we have that trial and error. We look at all the possible factors, 99 possible factors of 6. It's going to be a little awkward. If you got it to that point, I'd be happy, okay? But we're going to let the math expert resolve the rest of it for us. It's looking around and trying to find factors that actually did find a factor of x equals 3. It remains to be seen whether or not this is going to factor. And the quadratic can't be factored, okay? So I guess we're going to have to answer x equals 3 as our answer, unless this thing is going to factor. And quadratically, it's probably going to lead to a negative discriminant. Let's see. Yes, negative discriminant. And so the only answer is x equals 3. Okay, so we got that one. That's all right. Finally, let's go and take a look at this one from the previous worksheet, number 19. Okay, again, we're just going to have to combine our terms where we can. We should look at this right here and recognize that that's log A plus log B. So we can do that. Of course, it always throws up the red flag for us, okay? At that point, I think I'm going to send everything to one side, setting the other side equal to 0. And now we have log A minus log B. So that's going to simplify out in accordance with this rule. Again, the red flag is thrown up, okay? And now we take it out of the log form into the exponent form. So this is going to be 10 to the 0, which is 1. So this fraction is going to equal 1, okay? So we'll do that. And of course, we're just going to cross multiply, okay? And we distribute. Looks like we're going to have an x squared term that's going to cancel out. Now this is an oddity because we have x squared minus x equals x squared minus x, okay? Which is implying that there are infinitely many solutions, okay? There are infinitely many solutions to this. And why is that? Because this thing comes down to a true statement, okay? Now, we can't say infinitely many because we have to restrict what goes in here for x as positive. So we're going to say all positive real numbers. okay, are going to be the solution. Let's see if the math expert agrees with that. Yeah, x cannot, x is greater than 1, okay? X is greater than 1. Actually, it has to be greater than 1 because if we put 1 in here, we're fine. But if we put 1 in here, we're at 0. So x is greater than 1. All values greater than 1 are acceptable solutions on that problem. Interesting problem. Now it really should not surprise you because I'm going to back up this a little bit and go back to the original problem. And the original problem says x squared minus x inside of here. Now, if I factored that by pulling out x, and now I've got the log of a times b, okay, which is going to come down to log x plus log x minus 1, which is the same as what I had on the right side to begin with. So it validates that all values of x greater than 1 are valid solutions